Hi, in this lecture, we will look at applications of differentiation and we will focus on experiment problems. In this lesson, you should be able to find the stationary points and also classifying the type of turning points by using the first derivative test. What is the stationary point? Stationary point is whenever we move like an object, for example like a ball, on this curve. Stationary means that the ball will not move at that point. And then here, as we are going down, the gradient is going down, so it's negative. The gradient is negative here, and gradient is labeled as dy over dx, so it's negative here. And while the ball is moving up, the gradient is positive. Stationary point is whenever the gradient is 0 because it's stationary, it does not move. And now here it is also a stationary point because the ball will stop for a while before it continues to go down. So here the gradient is also 0, and at B here the ball will stop for a while before it moves again. So this is also considered as a stationary point where the gradient is equal to 0. And after that, when the arrow is going up, that means the gradient is increasing. So increasing gradient means that dy over dx is positive. When the arrow is going down, so this means the gradient is negative. And here, both arrows are going down, so here both gradients is negative value. At point A, when the gradient from the left side is positive and the gradient on the right side is negative, so one line is going up, one line is going down, so this is what we call as the maximum point. So A is a maximum point. And at B, we see that on the left, the gradient is negative, and on the right, the gradient is positive. So when it's negative, this means the line is going down, and when it's positive, the line is going up. So exactly in the middle of those two lines is that stationary point B. And here, this is what we call as the minimum point. So the points at A and points at B are being called as stationary points, or also known as the turning points. And their gradient at points A and also at points B will always be 0. Let's look at example 1a, finding the stationary points of the curve. Remember, when you see the word stationary, you have to remember the gradient dy over dx is equal to 0. So how to find that point? We have the equation y, so we just have to differentiate that y. To differentiate it, just differentiate as usual, bring 3 to the front, multiply with 2, x is power 2 left, and then behind, it will just be negative 6. Now, to find the stationary points, the gradient is 0. So just equate that to 0. Factorize your 6. Divide 0 with 6. So you're left with x squared minus 1 and press your calculator. You will get x minus 1 times x plus 1. So there are two values of x. So what will be the points? X is not enough because a point must be in a coordinate where we have the x and also its partner y. So to find the value of y, just have to substitute that value of x that we have just found into the equation of y. When x is negative 1, y is 5. When x is 1, y is negative 3. So the coordinate of stationary points are negative 1, 5, x negative 1 with the partner 5, and when x is 1, y is negative 3. So write them in coordinates. And now we have solved for example 1a. Now try out example 1b. Also try example 1c. The same method applies. When the question wants you to find the stationary points, this refers to dy over dx is equal to 0. So now we have two variables, x and y. So differentiate this implicitly. Get your dy over dx term equal to something, and then just equate all of that with 0. Solve to find your x, and then just substitute that value of x into this equation to find your value of y. Try it out. Now, once you have found the stationary points, how are we going to know whether the stationary point is a maximum or minimum point? So there are two methods to determine whether it's a maximum or minimum point at that stationary point. The first method is by using first derivative test. The second method is by using the second derivative test. But in this lecture, we will focus on the first derivative test. To use the first derivative test, from the name itself, we already know how many times to differentiate. So this is just differentiating one time. First derivative test means just the first differentiation. So this is just dy over dx, not the second order of differentiation. The second derivative test is where you have to differentiate one more time after you have differentiated the first time. Now let's look at this first method. After you have differentiated dy over dx, then if it is negative on the left of the point and positive on the right, then it's a minimum point. This means that if we have the value of dy over dx equal to negative on the left side and positive on the right side, so when it's negative, the line is going down, positive, the line is going up. So right in the middle here, when we try to connect these two lines, you see that it's actually a minimum point. So that's why when it's negative on the left and positive on the right side, then it will be a minimum point. Now, if dy over dx is positive on the left and negative on the right, so positive on the left means the line is going up, negative on the right means the line is going down, and if you try to connect these two points, you will see that it's actually a maximum point. Remember, when the gradient dy over dx is negative, it means that the line is going down, and when the gradient is positive, that means the line is going up. And then just trying to connect these two lines, you will see that the first graph here refers to a minimum point, and the second graph here, when we connect these two lines, refers to a maximum point. Now let's look at example 2a. Find the stationary point of this equation and determine whether it is a maximum or a minimum point. So the first question wants us to find the stationary point. Remember, when we see the word stationary point, we have to remember dy over dx is equal to 0. So our first step is to differentiate this y equation. After you have differentiated, just equate it to 0 and find your value of x. Your x is equal to 2. So we want to find a stationary point. Since the value of x that we have obtained is only one value of x, so that means there's only one stationary point with the coordinate x equal to 2. But what is the coordinate of y of this point? So to find that value of y, just substitute this value 2 into the x of the equation. And then you find your y. So the y is equal to 1. Substitute that 1 into your coordinate. So 2, 1 is the stationary point. Now we want to determine whether this stationary point to 1 is a maximum or minimum point. To determine, first step is to draw a number line. Make sure your number line is for the number x. And x here is 2. So try to imagine that this is like your x-axis. Plot your value of coordinate on that number line. And our coordinate that we are looking here is at 2. So plot 2 at the x-axis. Next, label on the right side of this number line refers to the value of x bigger than 2. On the left side of this 2 means that it's the value of x less than 2. Next, draw a table. So just draw a line right at that 2 and then just draw a line going downwards. So this refers to 2 right in the middle of this line, and greater than x greater than 2 will be on the right side of 2, x less than 2 will be on the left side of 2. So the values of x that we can choose, it can be any value less than 2. So the easiest value is 0. So at this row, you can choose any number which is less than 2 or any number which is greater than 2 for this column. Next row is for values of dy over dx. Previously, we have found dy over dx equal to 2x minus 4. So now, we just have to substitute any value which is less than 2. And for this question, I have chosen 0. So substitute that value of 0 into this dy over dx and see whether the sign is positive or negative. So 2 times 0 is 0, minus 4 will be a negative number. So write a negative sign there. Next, substitute a number greater than 2. So for this question, I have chosen number 3. Substitute the number 3 into this x. 3 times 2 is 6, minus 4 is positive. Now, draw your slope. If it's negative, draw a line going downwards. If it's positive, draw a line going upwards, like this. And then connect these two lines. And what you see is it a maximum or minimum point? Well, it is actually a minimum point. So write your conclusion. Now, the stationary point that we are looking at is the point 2, 1. So write your conclusion. The coordinate 2, 1 is a minimum point. And you're done. Now, one more example. Find the stationary points of y equal to 6x squared minus x cubed and determine whether it is a maximum or a minimum point. So, the first thing that we want to find for this question is the stationary points. Remember, whenever you see the word stationary points, we have to remember the gradients dy over dx is equal to 0. So, first step is just to differentiate this y equation. And what you get is 12x minus 3x squared. Equate it to 0. You can factorize 3x, and then from here you will obtain x equal to 0 and also x equal to 4. After that, we have to find the stationary points. It must be in terms of coordinate. So substitute your value of x into the y to find your coordinate of y. So y is 0 when x is 0, and when x is 4, y is 32. Write in terms of coordinates. If you do not write this sign, then you will not get the final mark, because the question is asking about stationary points, not the value of x and y's. So write in terms of coordinates and write this sentence. Next, we would like to know whether these 2 points are maximum points or minimum points. Now start by drawing your number line. Look at your value of x. We have x equal to 0 and also x equal to 4. Draw your number line. Now for this question, we have two values of x, of stationary points, which is x equal to 0 and also x equal to 4. So write both values on your number line. So this is a number line. Make sure you follow the order. The smallest number is here, and then followed by the larger number. Now we have two values of x. So we are not going to have 3 columns like the question before, where we have 1, 2, 3 columns. Since we have 2 stationary points, we will have more columns. Okay, so how are you going to draw your columns? Okay, after you have drawn the number 0 and 4, add one more line after 4 and one more line before 0. After that, just extend your line. Extend your lines. Okay. After that, just draw your rows. There would be 3 rows. First row, second row, and third row. Make sure you write the numbers of the stationary points clearly above. Next, the first row would be for values of x. The second row would be the values of dy over dx. Is the sign positive or negative? And lastly is the slope. Is up or going down? Okay, what will be the values of x? You can choose any number. Now, this is value of 0 here. So this means to the left of 0 is a value less than 0. You can choose any number. Let's say you choose -1. After that, a number between 0 and 4. Any number. So any number between 0 and 4 that you can choose might be number 1. You can also choose number 2 or 3, or maybe if you like 3.5. any number, as long as it is between 0 and 4, and not 0 and not 4, besides 0 and 4. Next number. The last column is for a number greater than 4, x greater than 4, any number. So let's say you choose 5. The next row is for the values of dy over dx. Now, what is your dy over dx? We have obtained it before. Your value of dy over dx is 12x minus 3x squared. Now, just replace your value of x that you have chosen into this dy over dx. Substitute in -1 and see whether you have a positive or negative sign. So when you substitute in -1, you see that you get negative. After that, substitute in +1 into this x. You will get positive. Lastly, when you substitute in 5 into that x, you get a negative sign. Now, the slope here is negative. So when it's negative, the line is going down. When it's positive, the line is going up. When it's negative, the line goes down. So connect these lines. Okay, the first connector will make these two lines looking like a minimum point. And when we connect this increasing line with the decreasing line with a connector, then you see that this is actually a maximum point. So this means we have to refer to the value on top. Now the value on top here is 0. So this means our coordinate with x0, which is 0, 0, is a minimum point. And now for this maximum point, looking up, we see that the x is 4. So this means the coordinate of 4, 32 is the maximum point. Write your answers clearly in a sentence. So 0, 0 is a minimum point, and 4, 32 is a maximum point. Make sure you write your conclusions clearly. Now, try out example 2c. The first question wants you to find the stationary points. So this refers to the dy over dx equal to 0. Differentiate this equation y, and then just equate it to 0. Find your value of x. After that, substitute that x into this equation y to find the coordinate of stationary points. After that, to determine the nature of the points, this refers to the question wants you to find whether it is a maximum point or a minimum point or an inflection point. What is an inflection point? Inflection point is whenever it's not a maximum or not a minimum point. For example, the one that I have drawn here. This is whenever the gradient negative for both or positive for both. And this is that inflection point. Okay, so try it out. Thank you for watching.